Today's lesson is on experimental and theoretical probability. Experimental probability is the ratio or fraction of the number of times that event occurs to the total number of trials that happens. So in experimental probability, you are going to do an actual experiment yourself. We are finding probability for what does happen. Now, before we were finding theoretical probability, which was the likelihood of an event happening based on your possible outcomes, and it is actually what should happen. So we're going to use the spinner below to answer the questions. I am going to simulate spinning the spinner 10 times, and we're going to complete the table together as we go along. On my spinner, I have labeled the sections stripes, stars, polka dots, and blank. So we want to spin this one 10 times. So here goes our first spin. Put a tally in one of the, it says white on our paper. I've called it blank on our page because our paper is orange. Okay, and now we want to, oh, it's still going for us. Good, I don't have to click spin again. So let's watch to the end on our tallies for spinning the spinner. All right, so on our table, it starts with stripes, and so our stripe section, it landed on the stripe section 3 times. On the blanks, we have to find all of the blank spots, so we had 2 plus 2 plus 1, and that was on white. So I'm putting a 5 in my total number of spins. Stripes, I've got 3 in the total number of spins. The polka dots, it landed 1 tally mark, 1 spin. And the stars, we've got a blank with stars that says 1 and a stars that says 0. And go down our tally and make sure that in here our number of spins is actually going to add up to the 10 spins. So I've got a 3, get back here, a 3, a 5, a 1, and a 1. And that does add to 10. And so now let's us take a look at what the theoretical probability is of actually getting these. Theoretical probability A of spinning something in the striped area. There is 1 striped out of 8 altogether, 8 options altogether. There are, letter B, spinning a section with stars. Well, there are actually 2 starred areas out of the 8 altogether. And we want the not spinning a solid or a striped section. Well, solid, I'm assuming, is going to be those 4 places. And a stripe is 1. So that's 1, 2, 3, 4, 5 that do have that stuff out of the 8, so it would be 3 eighths for the not. Now, we're going to compare these with the answers down below, so we want to make sure that we are converting things to like forms. For example, 1/8 as its rightful decimal is 0.125, aka 12.5%. Your 2/8 is just a quarter, which most of us have memorized as 25%. And 3/8, when you grab your calculators, it's 0.375, also known as 37.5%. Sorry about that messy 7. So that's what should happen when we spin the spinner. Now let's find out what our experimental probability was for getting these stripes. All right, well, we had 3 out of the 10, and this is going to be so convenient to convert to decimals than percentages. And so this would be a 30% of the time in our experiment we landed on stripes. Well, up above, you can see the theoretical probability of getting stripes was 12.5%. White, or blank, as I put it on ours, was 5/10, which is 50% of the time that happened. And white, or blank, up top was 1, 2, 3, 4 out of 8, which happens to be 50%. Dots was 1/8, which is 12.5%, and we actually got 1/10, which is 10%. And the same with our stars. And so number 2 says, are there any results in which the theoretical and experimental probability are the same? And actually, for the blank or the white spots, we had 50% theoretical, and we actually had 50% for the experimental. Going on to the next spinner, we are going to now use our experimental probabilities to make predictions. So the relative frequency is just the total number of successful attempts. And we're going to divide it by the number of trials we did. It can be used to make these predictions. Before we found the relative frequency over the total number of trials, we converted them into percentages so that we could compare with the other data. As your number of trials increases, your relative frequency of an event, also known as your experimental probability, they will become closer and closer together. Your experimental will approach your theoretical. Here's a new spinner, and somebody's already spun these things for us, and I want this little box to go away. Come on, get out of my vision. Thank you. We've got a spinner. This spinner was spun 50 times, and the people here put the results right here, and you're going to find relative frequency, which is just what is it as its fraction / percentage. And then we are going to simulate doing it 100 times. So take a moment to fill in the relative frequency and convert to percentages in each box so that we can compare these easier in the last column. Take a moment to do that now. All right, continuing now to our next spinner with the sections 1 through 5. I have over in this tab. And we filled in the data, for our relative frequencies. We have 24%, 12 times it landed on a 1. 8 times we landed on 2 for 16%. 13 times we landed on 3 for a 26%, 10 times on the 4 for a 20%, and 7 times on 5 for a 14%. We are now going to just take a look at the simulator, and we're going to spin this 100 times, and let's see if we get values that are getting closer to the actual theoretical probabilities of each of these numbers. So here on the colors in the blue area, this is where I have my number 2 placed because that's where it is the best location on our spinner on our note page. And then the 1, a 5, a 4, and a 3. And so here goes 100 spins. But we really don't have to sit here for all 100 spins. I'm going to click skip to the end, and let's record that count on our notes packets. Please take a moment to fill that in on your notes packet. Be careful of the numerical order. In the number 1, we're going to have 18 over 100, which you all know which percentage that is. Actually, in the 1 column, we should put a plain old 18. Whoopsie, sorry. We should put a plain old 18, and then since we spun it 100 times, let's put the plain old 18% down here. For the 2, we got a 29%, and we can see it right here in our experimental probability. That is pretty cool. I didn't even notice the theoretical column last. So the 2, we've got 29 times. The 3 is 16 times. 4 is 21 times. And the 5 is another 16 times. And again, we can put our 18%, 29%, 16%, 21%, and finally 16%. 16, 21, and another 16. Now, when we spun this little simulation 100 times, now, and on our graph, or if we go back to our simulator, here it says in this column, our theoretical probability of getting any of these is 20% because it's 1/5. So we were pretty close on the number 1, closer on the number 4. What do you suppose would happen, kiddos, if I bumped this up? And let's see if the simulator will let me spin this 1,000 times. We should get even closer with our 2 values. Experimental, meaning relative frequency, getting closer and closer to that theoretical. Let's watch a couple before I skip to the end. Oh, there, the 1 caught up. That number 5 has to catch up. All right, let's jump to the end. Yeah, take a look at that. This was 1,000 times. We are getting very close to having our relative frequency, aka experimental probability, equaling our theoretical. Let's see if they'll let us spin it 5,000 times. Hey, they let me type it. Oh, nope, 1,000 was the max. So, what do we notice as we spin the spinner 100 times? I'll try to type even though I'm missing the letter H on my keyboard. The more we spin the spinner, the closer our experimental probability aka RELATIVE will be to the THEORATICAL. All right, so we've got the work down here. Number 5 is the same answer that we just had. Back to my pen. How does the frequency change? The more we spin the spinner, the closer our experimental will be to our theoretical, because we even went 1,000 times. And we actually have the results from there, but the closer we get, it will be our 20%. Ours were actually 21, almost 19, a little over 19, and another 21. That's your lesson for experimental and theoretical probability.